Here we're looking at lesson 61, which has an interesting title of Playing Games with f, f prime, and f double prime. Really what we're going to be doing is looking at functions, the derivatives, and the second derivatives to help us solve for some variables. So let's hop in and look at this first example. It says given that f of x equals ax cubed plus b, and that the graph of f passes through the point 225, and that f prime of 3 is 81, find a and b. So what we're going to do is we're going to start off with our function, but we know that when we put in x, we will get 25. So I'm going to go ahead and write f of 2, which means we put 2 in for our x value. So 2 cubed plus b. And now we also know when 2 goes in, we're going to get 25. So instead of writing f of 2 here, we know our y value, or f of 2 value is 25, and we can say this is 8a plus b. Can't do a whole lot else with that. We have an a and b in there. So let's come and use this second piece of information, that the derivative at 3 is 81. So first of all, we're going to go ahead and take the derivative of our original function. So f prime of x is going to be equal to, we're going to take the derivative, and this is 3a x squared. And that's it, because the b is a constant and the derivative of a constant is 0. So now let's plug in our 3 value, and this will be 3 times a of 3 squared, or times 3 squared. Again, we know that f of 3 is 81, so we can replace this with 81. Simplifying this side, we get 27a. And now this is a nice simple equation to solve. Divide both sides by 27. You get a equals 3. Now that we know a, that's part of our answer. We wanted to find a and b, so there's a. We're going to go ahead and plug that back into our other equation. So we have 25 equals 8 times 3 plus b. We would subtract 24 from both sides, and we would get b equals 1. And that's it. We found a and b. Next, we have a function f is a real quadratic function whose graph passes through 2, 9 and 0, 1. And the slope of the graph is 6 at x equals 2. Well, the fact that we have these points here, that's going to help us figure out a couple things. And so what we're going to first do is take just a general quadratic function form. So let's say y equals, and general quadratic function form is ax squared plus bx plus c. And we're going to take that and we're going to use both of these points. So this will actually give us two new equations. So we know when we put in 2 for x, we'll get 9 for y. So I'm going to do that. So when y is 9, x is 2. Let's go ahead and figure this out as we go along. If we put 2 in here, we get 4 plus b times 2 plus c. We can do the same thing with 0, 1. This works out nicely, because when we put this in here, our y value is 1. Our x value is 0, so we're plugging into here. Well, this will be 0. This will be 0, and we just get c. So we actually solved for c, so we know our c value is 1. And we'll come back to some of this stuff later. The slope of its graph, well, we know slope of a graph has to do with derivative. So it's 6 at x equals 2. So what we'll do is we'll take the derivative of our function. Let's write it over here. Y prime is 2ax plus b. And we know the slope is 6. So our derivative is 6 when x is equal to 2. And we still have plus b. So we can rewrite a couple of these. Here, let's make this a little nicer. This is 4a plus b equals 6. over here, we know that c is 1. So I'll go ahead and subtract 1 from both sides, which would give me an 8. Oops. And then we have 4a plus 2b. Well, this is a very nice system of equations to solve. We can go ahead and subtract the first one from the second one. So we'll just go ahead and make all these negative. It's like multiplying by -1. And we will get 0a, we get b equals 2. So we know we can plug this back into one of our equations. Let's plug it in this one. So we have 4a plus b, which was 2, equals 6. If we subtract 2, we would get 4, and then divide by 4, we get a is equal to 1. And so we have b equals 2, a equals 1, and c equals 1. And actually it says find the equation of f, so actually I put y equals, I should have put f of x equals. So really what they want us to do, which I shouldn't have circled those answers yet, they want f of x. So f of x, our function, had a was equal to 1, so we'll have 1x squared, or just x squared, plus bx, well b we found was 2, so plus 2x, plus c, which was equal to 1. And there is our quadratic function. All right, our last equation doesn't say much. The second derivative is 10, the first derivative is 0, and the first derivative at 0 is 2, and the function at 0 is 3. What's the equation of the function? Well, if we start with this second derivative is equal to 10, we can actually work our way back to finding the first derivative. How do we undo a derivative? Well, we take the integral of it. So if we take the integral of this, this is going to be f prime of x. So we're integrating the second derivative to give us the first derivative. Well, this will just be 10x plus c. But now we know some information about this first derivative. We know the first derivative, when you plug in 0, is equal to 2. So when we put 0 in for x, so 10 times 0, we get that it would equal 2. So this actually tells us that this constant here is equal to 2. So c equals 2. I'm going to put a c sub 1 here because this is our first c that we're talking about. We might have to deal with one a little later. So putting this back in, we actually get f prime of x is 10x plus 2. Now we want to get all the way to what is the equation of the function, so we want f of x. Well, to get from a derivative to the actual function, we can integrate again. So we're going to integrate this. So this would be, this would come up to an x squared, but a 1/2 would come out front, so half of 10 is 5, plus 2x, again plus c. This is why I had that c sub 1, so I'll put this as c sub 2. And we know this information. When you plug in 0 to the function, you get 3. So if I put in 0, I get 3. So this is 5 times 0 squared, which is just 0, plus 2 times 0, plus c sub 2. Well, this is 0 plus 0 plus c sub 2 is 3. So c sub 2 equals 3. And now that we know that, we know what our function is. F of x is equal to this 5x squared plus 2x plus that constant that we found, so plus 3. And there is the function they were looking for.